Welcome back to Lesson 2. Here we're going to look at the effect of different compounding periods. So example 1. Joe is trying to determine which bank he should invest his $2,000. All banks are offering a 4.5% interest rate, but each have different compounding periods. Complete the chart to determine which bank he should choose. So here we have 4 different banks, and we have to determine the interest rate R, the number of compounding periods T, and the future value of the money in 5 years. So let's start with Bank 1, which is compounded semi-annually. So now the interest rate is going to be 4.5% change to a decimal, and then divide it by 2, because semi-annually means twice a year. When I do that, I get 0.0225. Now for the number of compounding periods, let's say that since it's compounded 2 times a year, over the course of 5 years, there will be 10 compounding periods. So now I'll plug those values into the formula. 2,000 times 1 plus 0.0225 to the power of 10. When I work that out, I get $2,498.41. Now for Bank 2. This time I'll divide 0.045 by 4, because quarterly means 4 times a year. So that's 0.01125. And the T value would be 4 times 5. So interest was applied to the investment 20 times over the course of 5 years. So for Bank 2, we would get a future value of $2,501.50. Now for Bank 3, we have to divide 0.045 by 12, because it's monthly. And that works out to be 0.00375. So now in total, there would be 12 times 5 compounding periods, or 60 altogether. So plugging that into the formula, I get that the future value at Bank 3 is $2,503.59. And then lastly for Bank 4, I have to divide 0.045 by 365. Now I don't get a nice decimal like I did for Banks 1, 2, and 3. So I'm going to say you should not round here, because your answer could be off a little bit. So we'll just keep it as a fraction in the formula. Now for T, I have to multiply 365 by 5. So interest is being applied 1,825 times at Bank 4. Now, like I said, when you put in the R value, don't put in the rounded decimal, just put in a fraction. So we know our answer is going to be exact. So just put that in the calculator by entering the fraction first, 0.045 divided by 365, then add 1 to that. Then use your exponent button to put it to the power of 1,825, and then times it by 2,000. So putting it in all at once will reduce any rounding errors. So here's what I get at Bank 4. So now to determine which bank he should choose, so let's look to see where he earns the most money. Well, at Bank 4, he earned $2,504.61. So I'm going to say Bank 4 for this. And what conclusion can you make about the number of compounding periods? Well, we started with 10 compounding periods, then we had 20, then 60, then 1,825. And what happened to the amount of money earned? It increased. So what we can say is that if the frequency of compounding periods increase, then the amount of interest earned increases as well. Then the amount of interest increases.